We're going to continue on with some problems relating to moles and Avogadro's number. This is page 148, example 5.6 in Exploring Creation with Chemistry. But this is still a good example for you to look through even if you're not using the same text. Our statement is this: people are encouraged to limit their table salt, sodium chloride or NaCl, intake to 5.000 grams per day. How many moles of sodium chloride is that? Now remember, a mole is just a number. It's 6.02 times 10 to the 23rd molecules of sodium chloride. That's Avogadro's number. So what we're going to have to do is realize that we have sodium chloride. And let me check and see where I am. We have sodium chloride. Now, is sodium chloride a compound or is it an element? Well, sodium chloride is a compound that is composed of two elements. We have the element sodium plus the element chlorine. They chemically combine together to make sodium chloride. Now, what we learned about Avogadro's number and moles is that if you have the same mass of either an element or of a compound in grams as the mass of that element or compound in AMUs, that contains 1 mole of molecules or of atoms. So what we're asking, how many moles of sodium chloride is 5.00 grams? So how do we find the atomic mass of sodium? The atomic mass of chlorine? Go to your handy-dandy little periodic table of the elements, or you may have one laminated in front of you. Sodium, which is Na, it's element number 11, it has an atomic mass of 23.0. Chlorine, which is element number 17, has an atomic mass of 35.5 AMU. So the atomic mass of sodium chloride is 23.0 plus 35.5 atomic mass units. So we have 5.85 AMU is the atomic mass of sodium chloride. Now what do we know from Avogadro's number? We know that if we have the same mass of the compound in grams as we do the mass of that compound when our units are atomic mass units, that's equal to 1 mole. So what do we know here? We know that 58.5 grams of sodium chloride is equal to 1 mole. 58.5 grams of salt, or sodium chloride, contains 1 mole of molecules. Has that molecules. And what is a mole? A mole is 6.02 times 10 to the 23. Huge, huge number. Now what does our question ask us? Well, this says we want to limit our sodium chloride intake to 5.00 grams per day. How many moles of that? Well, 1 mole of sodium chloride is 58.5. We don't care about 58.5. We want to know how much 5 grams of sodium chloride is. So, if we have 5 grams of sodium chloride over 1, and we want to find out how many moles that is. Well, this right here, 58.5 grams of sodium chloride is 1 mole of molecules. So 1 mole contains, where 1 mole is 58 0.5 grams of sodium chloride. Grams of sodium chloride cancel, and you have 5 divided by 58.5. You plug that into your calculator and you have 0.0855. 0.0855 moles sodium chloride. Why did I do 0.855? Because I need 3 significant digits here. Because 58.5, I have 3 significant digits. 1 is an exact number, so we don't worry about significant digits there. So we're going to have this 8.5 hundredths, or 85 thousandths, of a mole of sodium chloride is the amount that it is recommended that we can consume in a day. So what we're doing, what we're seeing here is that we can take something that's easily measurable. You get out your mass scale and you can tell me the mass of something in grams or kilograms, whatever it needs to be. And you can convert from mass, which we can do, to the number of molecules of something. And that's why this mole, this whole idea of a mole concept is so valuable. So let's go ahead and see what we have now. There's an experiment next. Let's go ahead and look at a sample problem. This is actually 5.8 of the On Your Own problems in our text, but it's still just a plain old ordinary sample problem using moles and calculate. This is problem number 5.8, and it is on page 151. And this says, how many moles of glucose? Glucose is C6H12O6, H12O6, are there in a 1.25 kilogram sample? Are there in 1.25 kilogram sample? How many moles? Not the furry things, the counting things. How many moles? So what are we going to have to do? First, we have to figure out the mass of 1 mole of sugar. How do we do that? Sugar is a compound. It's composed of more than 1 element. It's composed of carbon, hydrogen, and oxygen. And each molecule of sugar has 6 carbons, it has 12 hydrogen, and has 6 oxygen. So we have to find the atomic mass of carbon, of hydrogen, and oxygen so that we can calculate the atomic mass of a molecule. Calculate atomic mass of a molecule of sugar. Of a molecule of sugar. So we have carbon has an atomic mass of 12.0 times 6 is equal to 72 atomic mass units. What's our mass of hydrogen? Look at our chart. If you haven't already learned that the atomic mass of hydrogen is 1.01, you will very shortly. 1.01, how many atoms of hydrogen are there? There are 12 atoms of hydrogen. 12 times 1.01 is 12.12 AMU. And what is the atomic mass of oxygen? You'll learn that that one is 16.0. And you have 6 atoms of oxygen. So you have 16.0 times 6, 6 sixes are 36, you have 96. Now what we do is we total to find the atomic mass of 1 molecule of sugar. We're going to total the atomic masses here. So we have 0.12, 6, 10, carry 1, 10, 18. We have that the atomic mass of sugar is 180.12. What we know now is that 180.12 grams of sugar make 1 mole of sugar. 180.12. 180.12 grams of sugar is equal to 1 mole. So how many moles are there? If we have 1.25 kilograms of sugar. Let's see if I like the way that I did this. Moles, da, 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 da. Don't think I do like the way I did that. I've got it upside down. We want to put the amount of sugar that we have. We have 1.25 kilograms of sugar. We're going to take that down to grams because what we're using to calculate our moles, we're using grams, not kilograms. So how many grams are there in a kilogram? There are 1,000. If we use scientific notation, what are we going to have? 1.000 times 10 to the third times 10 to the third grams. Now our kilograms are going to cancel, right? Let me see how much room I still have left. Now, we learned that a molecule of sugar has an atomic mass of 180.12 AMUs, which tells us that 180.12 grams of sugar makes up 1 mole. Now our units are going to cancel, and we have 1.25 times 10 to the third, 123, which is 1,250 grams, which canceled, divided by 180.12 moles of sugar is how many moles of sugar we have if we have 1.25 kilograms, which is just under 3 pounds of sugar. So let's go ahead and do our calculation. 1250 divided by 1820, 180.12. I'm looking for the problem that this is, since I don't have a good calculator. Actually, I do have a good calculator handy. It's right here. This is problem 5.8. And we have 1250 divided by 180.12 gives us 6.939 blah-diddy-blah-diddy-blah. How many significant figures? The most that we have right here is 3 significant figures. This is an exact number, so we don't worry about significant figures. We're limited by the 1.25. We have 3 significant figures. So this is going to round to 6.94 moles of sugar. And that's yet another example of how we're able to convert from mass, which is how much something weighs in our simple little mind, from mass to the number of molecules. 1 mole contains Avogadro's number of molecules, 6.02 times 10 to the 23rd. So it would be 6.02 times 6.94 times 10 to the 23rd, which is an unimaginable number of molecules that make up 1.25 kilograms of sugar. And that's the end of this.